video, we will be looking at LeetCode challenge problem count square submatrices with all ones. Here we are given a m cross n matrix in which we have to find how many square submatrices are there which are all of ones. So here we can see 0, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1. So here the answer is 15. Let us look how we got to that 15. So how many 1 cross 1 matrices are there, which is like single element 1? Those are around 10. Here 3, here 4 and 3. So totally 10. 1 cross 1 matrices are there. And next we'll see 2 cross 2 matrices. How many 2 cross 2 matrices are there? So here we can see like this is 1 matrix, 2 matrix, 3 matrix and 4 matrix. So totally 4 are there. And how many 3 cross 3 are there? We can get here overall 1 3 cross 3 matrix. So we if we add up, we get it 15. So the brute force approach for this problem would be what we have to do is we have to iterate over all the elements and see how many square matrices we can make from that element. Say if we are from here, since it is 0, we can't make a square matrix with all ones since the first element itself is 0. So we'll check from here how many we can make. 1, 2, again 3 matrix we can make. So from here we can make 3 matrix. So like that we have to do it for every element, like from 1 and we can make 2, again plus 2. Like that, if you add upon all the elements, all the submatrices from each element, then you will get the final answer. But this would be an order of n to the power of 4. Since we are iterating all the elements, so that's why we get an n square, and we have to check for each square element. So that would be another n square. So totally n power 4, which could be like since the array length is 300 and we are doing n power 4, we'll get time complexity is around 300 to the power of 4, which is greater than 10 to the power of 8. So we will encounter here a TLE, time limit exceeded error. So what should be the approach here? Let us make some observations. And since we are calculating the repeated results in our brute force method, we were calculating repeatedly. Can we make a use of those repeated calculations and somehow store them and use the answer back? So here, if you want to see how many matrices of 1 can be made from here, that is nothing but the maximum size of the matrix. Here we got 3 matrices from this position: 1 matrix, 2 matrix, so 2 cross 2, and 3 cross 3. So the one observation we can make is the number of matrices from each element position is nothing but the maximum size from that element. How much whatever is the maximum size square matrix we can make, that will be the number of matrices that we can make from that element. Okay, so if we can make a, how we have to see like how we can get the maximum element. For each element, we will try to calculate the maximum square matrix, and then we will add all of them, and finally our answer would be that. But how to find out like what is the maximum size of the matrix from this element? So the maximum element, let us use the calculations that we do from the bot these two elements. So the maximum element would be from let us see this maximum element and this maximum element. So what happens is from here, if you try to see a maximum size, what we can make from the left and the bottom, that would be 2 and 2. But 1 plus 2, we can make it. But what if this was 0? It can't be a 3 cross 3 matrix. So we have to also consider the diagonal element here also. So in this case, what will be the maximum from this element? It will be, if you make a careful observation, 1 plus minimum of 2 comma 2 comma 1, which is nothing but uh, this is the two size matrix that we can make, this is the two size matrix we can make, and this is a one size matrix we can make from the diagonal element. So using this logic, and we can make a dynamic programming solution for this, which is like bottom up solution, where we will try to see from the bottom element, bottom right element to the top left element, moving from right to left and bottom to up. Like this, we will try to find out the each element how much, what is the maximum uh, size of square matrix we can form. While finding out this element, we will add the result, and overall our answer will be the sum of all those maximums at each element. So for this, the order of complexity would be n square. So let us see the uh, code. We have the code. Um, what we are trying to do is we are taking an element answer is equal to 0, and we are trying to find out the n and m, and which is the length and breadth of the matrix, and we are making a dynamic DP array with initialized with extra space 1 here, and we are iterating from, as we have seen in our solution, we are trying to iterate it from bottom position towards the up position. Okay, so let us see this. So that's why we are moving from this element n minus 1 and m minus 1, which will be the last element. And whenever we encounter 1, then we are trying to do is dp of, we are trying to take the left element, bottom element, and diagonal element, minimum among those three elements, and we are trying to get the answer, and we will try to use the answer. While we are getting the answer, we are which is the maximum size we can get from that DP, from that element. So we are adding up to the our final answer, and we will return it up to the we will return it the sum of all those answers. So this is the approach and the code. So let us run that. So our code got accepted. Let's submit it. So yeah, our code got accepted. So that's it. Thank you.